Hello again, all you wonderful bio students. We're going to continue our video lesson on cell respiration by kind of doing our second overview, but then we're going to dive in. And again, remember our phrase, we're going to watch for those falling electrons. Where are they going? Now, hopefully you saw on and practice that what we have. Let's go ahead and move these over. And I tried to match. I don't know if you caught it. I tried to match the colors somewhat successfully. But there we go. We have glycolysis in the cytoplasm outside the mitochondria, Krebs cycle in the matrix, and then we have the electron transport system on that, or chain, on that inner membrane. Now this diagram is more a schematic. It just kind of outlines everything. It's not the most visually helpful, so don't worry if you're thinking to yourself saying it says inner membrane, but it doesn't look like it's on the inner membrane. You'll get lots of different diagrams of models that show this, and this is just one of them that kind of shows step by step. So here's our first step, glycolysis. Let me go over the basics. What we're going to do is take glucose, and again, you can follow along. Let me move this guy over here. There we go. So we're going to take glucose, C6H12O6, and we're going to break it down to a molecule called pyruvate, and we actually get two of these. Now, you could do this a couple of ways. If you want, you can make another copy of that pyruvate, whatever works for you, or you can put two in the text box, whatever works for you. So we're going to take glucose and we're going to break it down into two pyruvates. You're literally taking a 6-carbon molecule, breaking it in half into 2 3-carbon. That's a little oversimplified, but you'll see what I mean. Now, from this process, you're going to be able to get 2 ATP. So let's move our ATP down here next to the little explodey guys. And remember, that is our goal. We want ATP. But 2 ATP is not a lot. Glucose is remember I said this before, glucose is like a $500 bill. Very powerful. Nobody would refuse a $500 bill. But imagine going to the bank with your $500 bill and asking for change. And the first teller you see says, yep, okay, here you go, here's $10. And so the first teller, you're looking at them going, wait, what? You're giving me $10 for $500 bills? I don't think so. And that's kind of what happens in glycolysis. We're only getting 2 ATP. That's not a lot. Now, there's going to be a secret here. Remember, watch for electrons and those hydrogens, because what we can get is a molecule called NADH. Now, I'm going to unpack that, so don't worry. Just follow along for now, and you guys can pause whenever you need to pause. So glycolysis, we're going to get 2 ATP, 2 pyruvate, and 2 NADH. And again, don't worry, I'm going to unpack those things in just a bit. Now, remember, 2 ATP is not a lot. So let's go to the next teller, the bank teller, and go to the Krebs cycle. Well, the Krebs cycle is only going to get us 2 ATP. And again, you're kind of like, wait, what? Go to the next teller and you still only get $10 of your $500 bill. That's nuts. Where's the rest of my money? Well, along with ATP, the Krebs cycle is going to be making some more of these NADH, 8 of them. And they're going to end up being a huge, sneaky player. So these are going to be like one of those characters in a show where they're in the background and you don't know what they're doing yet, but they end up being very crucial. I'm reminded of Neville Longbottom in Harry Potter. He was always a minor character until the very end, then he's important. So NADH and FADH2, they're going to be very important. But for right now, let's just go ahead and put them in there. We're going to be making them. So 2 ATP, not a lot. 2 ATP, not a lot. What's going on? Where's the rest of our $500 bill? Where's the rest of our energy? Well, it's going to come back in our electron transport chain. We're going to be able to get 26 to 28, and then other books say 30 to 32. It's but somewhere around 28 to 30 if you want. To 2 to and then 26 to 28. So that's going to be our big payout. That's huge. That's super great. So we're going to get a lot more ATP, just like you would get a lot more money in that third teller at the bank. However, no energy transaction is fully equitable, right? That's just good old entropy. You guys might recall that from your physical science days or middle school days. We always lose some energy to heat. Your car engine is a good example. Car engines never have fully 100% energy transfer. You lose some as heat. So we're never going to get our full $500 back from our glucose molecule. You're going to lose some. We're about 30% efficient, which is not too bad for machines. All right. So that is our overview. And again, these are going to be really sneaky characters here. We're going to want to watch them. So let's dive into specifically glycolysis. And I'm going to tell you right now, as soon as I go to the next slide, focus on that bright yellow box. All right. You do not need to memorize this. It is a mess. It looks awful, and I get it. And I'll tell you, I don't know it all. I know a few steps because I've been teaching it so long. So let me reassure you, you do not need to know this whole crazy diagram on the right. But I also show it to you so you can at least see some parts. And sometimes that's actually very helpful because if I just write things out, you're just like, okay, what does that mean? And I at least want you to see it. But please know, you don't need to memorize this. So glycolysis, we're going to take glucose, and through 10 steps, we're going to be able to start nibbling away at some of those electrons and strip them away. And we're also going to be able to make some ATP. So what are the main what are the main goals? Well, through 10 steps, we want to prep glucose by adding to ATP. That means we're going to boost it up a little bit. Now, that means we waste 2 ATP. We're putting ATP into the system. And that can drive some students nuts. I get students looking at me and going, wait, you're telling me that ATP is so important and that we want ATP, and then you're telling me that we're putting 2 ATP into the system. And that's because we need to jumpstart the system. It's like the boulder on the top of the hill that needs a little nudge. And then as soon as we nudge it, the boulder falls down. That's what's happening. We're going to add 2 ATP, and that's going to get everything started. So notice a couple of things in this diagram. And again, you don't need to memorize it, but notice we're going to start with this crazy big glucose molecule. And then notice by the end, we have a 3-carbon molecule that is missing some hydrogens. If you count them up, you don't have to, but if you counted them up, you would notice if you just split this molecule in half, it's not the same. We have removed some electrons and hydrogens. And again, here's our nibbling process. We're capturing these high energy molecules. We're going to capture them in NADH and 4 ATP. So we're going to make 4 ATP and 2 NADH. But then you got to remember, we added 2 ATP into the process. So if we were to look at a net gain, we only gain 2 ATP. So this one's kind of nice because it all rhymes. 2, 2, 2. 2 ATP, 2 NADH, and then 2 pyruvates. And that's going to be important, that 2. So glycolysis, the important thing to pick up on, we're taking glucose with all of those lovely high energy electrons and hydrogens, and we're going to start the nibbling process by stripping off some of those electrons. And just so you can see, you can kind of see the fact that some of these hydrogens are gone. They're now in NADH. Now, we kind of, I want to show you, like, okay, what's up with this NADH? And it's going to be very similar to NADPH. And so I found a little video clip that does a really nice job. Let me mute it. We don't need to hear it. But this kind of shows you, again, here's our glucose that gets split. We got to add ATP in to jumpstart it, and then we get 4 ATP out. And then notice here's our NADH. So this video does a fantastic job. Look at our little dump truck here. Let me go ahead and play it. So NADPH would be our mobile electron carriers. So NADH holding those nibbled electrons and hydrogen. And notice what it's going to do. Let me sneak back just a bit. We're going to have NADH, and it's going to dump it somewhere. And then, okay, so it's going to then go back and get electrons, more electrons, and go back and forth. There we go. It's going to do it again. Yay, so that's NADH. Fill it up, dump it, fill it up, dump it, fill it up, dump it. That is its job. Now, don't worry about this. They go into a little bit of extra stuff. Now, here's another one that you're going to be introduced to called FADH2. And just as the other one, this has a crazy name to it. Flavo something, I can't remember, which means you don't have to know it. FADH2. But FADH2, they're using as a little bulldozer, or that may not be a bulldozer, but anyway, and it's holding electrons and hydrogens. So all of these molecules are mobile electron carriers. So you can see here it is carrying electrons and hydrogens, and it dumps it and goes back. So that's what we're going to notice with our NADH and FADH2. They're just going to pick up electrons and then dump them where they need. So that's what we're going to start seeing with all of these guys. All right, so this is question time. So what you guys are going to see, and Krebs cycle is so infamous that you can, there's so many memes for Krebs cycle. But let's pause, or this will be the end of this video. Question time. What does glucose have that we want? Go back on the slides if you need to find that. What are the 3 main steps? And you can even include the little half step in there if you want. Where does glycolysis occur? And what are we going to nibble and get? And then even I'll throw out another one. What were the 2 mobile electron carriers that we just saw in the little video? So, all right. So that should give you guys some questions to think about in class and discuss. And I will see you again.